Let's dig a little deeper into the properties of capacitors. Let's say you have a fully charged capacitor. You have the battery on it, you've separated as many electrons as you can from up here, and we're in a stasis, we're at equilibrium. Let's disconnect the battery, take him out of the circuit, and change either the area of the plates or the distance between them. Don't ask me how we're going to do that from an engineering point of view, we're just doing concepts here. What do you know about the total charge on the capacitor? Think about the conservation of charge and how charges were flowing in this system before going to the next slide for the answer. The charge remains the same. There's no place for it to go. Charge needs to flow through a conductor, and once the battery was disconnected, once it's not here, there's no conduction path, so no charges flow. Charges can't flow between the conductors because air is a great insulator. So the conservation of charge tells us that the charge you start with is equal to the final charge. That's why you should never handle a capacitor if you don't know where it has been. It might be holding a charge. It can hold a charge for a long time. And if you were to somehow put one finger here and one finger there, which would be very easy to do because capacitors don't have to be that large, you will discharge all those charges through your body into the ground. That can be very dangerous. Imagine you have a fully charged capacitor. This time you're going to keep the battery connected and somehow change either the area of the plates or the distance between them. Again, don't ask how we're going to do it. We're just trying to illustrate some concepts here. What do you know about the new voltage between the plates? Before going to the next slide for the answer, here's a hint. Think of the conservation of energy. The voltage remains the same. Voltage is the amount of energy delivered to each charge as it passed through the battery. Since the battery is still hooked up, it maintains the same potential difference between the two plates. That's because energy is conserved regardless of how you change what the capacitor looks like. Since the energy stays the same and voltage is the energy per charge, the voltage will stay constant.